Hello, thank you for having me at the conference. Thank you all for being here. My name is Alex Eagle. I work on the Angular team in California. I mostly work on compilers and build tools. So if you ask me things about how to write a front-end application, I don't know that much. I mean, a little bit. Probably not as much as most of you. But it's good to specialize. So I don't have a lot of time. I want to try and run through a lot of stuff. So before we talk about optimization, let's make sure we know what we're optimizing for. So we like the web. Adam Bradley's talk reminded us how much we like the web. And one of the great things about the web is uniform resource identifiers, right? We have this way of taking a link and we can stick it in our Twitter feed, and then somebody sees a little pop-up image and it's a preview of this site and they can click it. And the key thing here is that these visitors don't care about our site at all, and they're probably ready to leave if the next Twitter thing that they saw looks interesting. And I know this is on the other hand, we have applications, and applications can do really cool things. So here we have a user who is hungry, and so we can have them order food and we can have it delivered to their house. So importantly, we can make a conversion in a monetary sense, right? Like this is important to our business. So how do we get between these two things? So how do we get this casual user the casual visitor to become a real user of our application? And of course, a lot of them fall off of this cliff. So this is drop-off or page abandonment. And how does that happen? There are obviously several things that can happen. But one of them is just that we took too long to show them something interesting to make the page interactive. And according to this research, if you wait 4 seconds, then you will have lost 25% of your users. So we might say that we have 4,000 milliseconds to get our page interactive. But maybe you want to lose fewer than 25% of your visitors. Maybe your target audience is particularly uncommitted because they, I know that if I spend 2 seconds and I'll just go back to Twitter and read the next thing because there's thousands of things to read on Twitter and no time. So the other factor, of course, is the speed of their connection and their hardware. So if we guess that we have a 250K connection, we have 500K to get our JavaScript and all the rest of our assets onto the page. And of course, we need to leave time for bootstrapping as well. And this 500K number is just an example, but you could actually use analytics on your site to try and figure out what your page abandonment is and what size you think you can afford. So the key takeaway from this for me is that there's a budget that you have to spend. And like any budget in your life, you can choose to spend it on one thing or another. And so not only do we want our JavaScript to be small, but we want to leave room for our UX designers to make assets that are big. We want to have like a full screen splash image behind our ordering page so that basically give the designer the freedom to make big things instead of saying, oh, like the JavaScript takes up most of the site, we can't afford this image. So of course, one developer working on a small app can easily or with a fair amount of knowledge, can write an application that's optimized and small. I'm sure many of you have done this. And you do it by thinking in terms of bytes and in terms of download time and in terms of performance while you're coding. So you don't write a bunch of extra code because you know that all that code needs to get shipped to the user. But of course, we work on Angular too because we work on larger applications and larger teams. We want something that can scale, so we don't want to have to think about bytes and performance the entire time we're writing our application. Obviously, in some cases we will. But what we want is for tools to do this work for us. We want to write an application that's maintainable, and then we want it to also happen to fit in our budget. So with that context about what we're optimizing for, of course the way we do this is with static analysis. And before I say what static analysis is, let's talk about the other kind, which is dynamic analysis, in which we run your code. So a tool can understand your program and can do things that are interesting with your program by running it, and this is actually what we do with Angular Universal. We run your program ahead of time in a node process on the server. But that has a lot of pitfalls because your application needs to be able to run in this other weird place. So if your application depends on running in a real browser, if it depends on some state that's local in like HTML5 storage, if there's a part of your application that the user has to authenticate in order to see it, then now you have to wire authentication logic and authentication tokens into your build system or into any tool that you run. And that's crazy. Tools don't want to be in the job of running your code. In fact, your code may not even terminate. We may start running it, and then the tool just hangs because there's something is wrong. So static analysis is, in this example, is what can we figure out about your code without running it? And this one is easy. Our team has a style guide. You probably also have a style guide. And we don't like these line breaks. They look kind of ugly. And so a tool fixes it. This is the basic premise of this talk. A tool will fix it. I should have like a sound effect that I do every time I say that. Bam! So we run gulp format. This is what the Angular team does to solve the formatting problem. And we wrote this, this gulp extension around a tool called Clang format that comes from the C++ world. But Martin Probst, who gave the talk on security yesterday, has done a lot of work to make it very good at formatting TypeScript code as well. And let me try and persuade at least a few of you who have a very particular taste for how your code should look, that it is worth it to have a tool just do the formatting for you. The white space is not worth it. That's the takeaway. So try running a formatter. The very first time you do it, you won't like it because it changed your code. And then from then on, you'll never have to think about formatting again. OK, another static analysis example. So here we don't like var. Var has non-lexical scoping, and so it causes weird bugs. And of course, now that we have ES6, we have let and const, which completely replace it. So the solution, bam, we run another tool to fix it for us. In this case, we can run tslint with a formatter that says to apply the fixes to the original source file. If you've never heard of this, it's because it's brand new. And actually, this was an effort from my intern, who's got the pineapple logo over the summer, Scott. He did a great job. So we hooked up into tslint the ability for it to understand TypeScript type checker semantics, so it knows the types of things. And it can also fix the problems that it finds. And just a couple of days ago, I saw from the Visual Studio Code team that they are going to change their plugin so that when you get a little light bulb that pops up on your code and it says something is wrong here, it will use the fix that comes from tslint. And of course, we can hook the tslint fixes into the command line and maybe into code review tools. Also, I've been doing some refactoring in the Angular code base lately, and I've been doing it by writing a tslint check that finds things like our usage of some old APIs that we want to remove, and I can just do the apply fixes to change it. But as you can see, and thank you also to Minko Getchev, who's been working on this, but the fourth person is you, and I'm not sure who I'm pointing at. But come talk to me afterwards if you're interested in helping with this. It could be as simple as just add a fix for one of the other rules in tslint, where this has a long way to go. This is the project that I hope may let us do more interesting refactorings so that we can help you move along to the next Angular version when that happens. OK, so getting on to the real static analysis that you're here for is, what about this? What's wrong with this code? Well, it doesn't have any mistakes in it. But even this very simple expression of interpolating name into this template requires that that Angular parse the expression. It's easy in this case, but it still needs to happen. And we need to compile this into the code that actually executes inside of the framework. And so, of course, this means we have to download Angular's compiler to the web page, and we have to execute it during Bootstrap. So this is extra size and extra time. And if we're working inside of a 500K budget, we really don't want to do that. The Angular compiler is about half the size of the framework. So I think it's something like 40 or 50K gzipped. So bam, a tool fixes it. So this is ngc, which you may have run if you've used Angular's ahead-of-time compilation. And ngc is basically, it takes the Angular's compiler, and instead of running it in the browser like it has with Angular 1 or with the JIT mode in Angular 2, it runs that same thing inside of a Node.js process on your machine, inside of your build tool. It reads your templates in, and it produces TypeScript code out. And of course, there's a lot of advantages of doing this. In particular, that TypeScript code that we print out lets you do type checking of the expressions in your template to find out that you have mistakes. Mishka talked about this a little bit in the keynote yesterday. But ngc is obviously more complicated than these other static analysis tools. So let me briefly go through the basic design, which is to add extension points into the TypeScript compiler. So this is how TypeScript works. The configure step is basically reading your tsconfig.json file. Then it needs to parse all of the inputs. So you've told TypeScript in your tsconfig, you say roots, or you give it a list of files, you give it includes, excludes, and so it goes and finds files on disk, and then those files have imports, and so it walks this whole thing to build up what is called a program. It's just a static representation of this data in TypeScript. Then it type checks this program, and it tells you your mistakes, and then, of course, even if you have mistakes, it will emit your JavaScript that you're looking for. So we've created a package called @angular/tscwrapped, which is internal to ngc. You don't need to install this package. But the idea here is simply to add extension points into TypeScript. The first one is pre-processing. So right before inputs are read off of the disk into the TypeScript compiler, we can change them in some way. And I'll talk about how we use this in a few minutes. We have a code generation extension point. So this is basically just a way of adding more source files to the program. And it can look at the files that are already in the program, and obviously we're going to read HTML and CSS files too. And importantly, this runs before type checking, and that's important that it's just a syntactic transformation because it means that we can do this more quickly. And then in scenarios like interactive development, we want to be able to do this very quickly. And this is the same design actually we borrowed from Java, which has a feature called annotation processors, where you can decorate things with annotations. It looks very similar to decorators in TypeScript, and it lets you generate code out of those. So if you've used dependency injection in Java, the most popular and I think best designed framework right now is Dagger, and it uses this feature to produce code ahead of time. The next extension point is to do more checking of your program. So TypeScript has added a lot of strictness features, which are useful to find mistakes, and so you can opt into stricter settings. So like -- strict null checks is something that Daniel mentioned yesterday in his talk. We don't have any of these yet, but this is a place where I would like to be able to take a TS-lint rule that's really about correctness and run it inside of the compiler so that you get that diagnostic just like you would get any type error in your program. If it's something that's really an error, we should show it there. And we can also add checks that are specific to Angular, so they don't belong inside of TypeScript, but we want to be able to add these into the compilation. Finally, we have a post-process step. So as the emit is occurring, we can either monkey with those JS files as they go to disk, or we can emit more files. So one example of an extra file that we produce here is the .metadata.json file that you may have seen if you've run the Angular ahead of time compiler. You may also have seen it if you've downloaded a third-party component that is AOT compatible. So this is simple to explain. The metadata.json file is just like the .d.ts file. DTS files contain the information that was lost when the TypeScript was emitted to JavaScript, but that TypeScript will need to type check this JavaScript file. So it's preserving some extra information in this side channel. So very similarly, the metadata.json file is a way of preserving information that was lost both in the JS and the DTS outputs that the Angular template compiler will need. And so we just stick extra metadata in there. So this is why if you publish a third-party component, we recommend that you publish JS, DTS, and metadata.json files. And this is where those are produced. So of course, TSC wrapped is really just something that we wish was in TSC. And since we have a great relationship with the TypeScript team, we've already been discussing with them how these extension points could work. There's some prototype code already in this branch that was worked on over the summer. And so my hope is that today when you run ngc, you can stick this extra block in your ts config file. This is one way of getting the configuration into the tool. My hope is that eventually this will just be you run TSC and we have an Angular extension that gets loaded into TypeScript, which would be really cool, and it means that as long as this extension is kept up to date, we can do things like add more static analysis. There's a second package. This is at Angular/compiler CLI. And the purpose here is just to run Angular's compiler. So I'm not going to talk a lot about the compiler right now. Tobias gave a great talk about it last month at the Angular Connect conference, so you can watch his talk to know more about it. By the way, we should call it the Tobiler because I think it's funny. Oh, somebody laughed. That's great. So the whole purpose here is we collect the static metadata. I've been talking about static analysis. So like we use it here, we input it, and then we produce the code generation that actually contains the TypeScript that we're going to execute. So now that we know a little bit about how ngc works, we go back to this example, we run ngc, and we get a lot of code. I'm not going to talk about all of the code. One thing I'd like to point out here is that when you run TypeScript's compiler, you're not running a compiler, you're running a transpiler. A transpiler's job is to take code in one language and output code in another language. And most of TSC's job is just to remove the types and desugar some things that don't exist in ES5 or whatever you're targeting. What Angular runs here is a compiler, and the point is not to produce code that you can read, which is what TypeScript is trying to do, but to produce code that's really fast to execute. And so your code may change as it goes through this process, and of course, as we make Angular faster, one of the places that we'll do that is by changing the kind of code that we generate. And this is the code that you could have written by hand, and if you were thinking about bytes all the time, like I said earlier, maybe you would write this code by hand. But since we want to be scalable, we let the static analysis tools write this code for us. A couple things I've outlined. One is that the generated code is just a wrapper around your code. So this is like an inversion of control pattern. We hold something called the context, which is really just an instance of the component that you wrote. When we see the h1 tag, and we're creating an instance of this component, our job is to tell the renderer to put an h1 tag into the DOM. And then later when we detect changes, we're going to interpolate the hello string along with this.context.name. And as Mishka pointed out earlier, this is more performant because we're referring specifically to this property, and we get the inline caching in the VM, which is cool. Okay, so let's move on. So far, all I've done is given you more code, right? So like now you have all these ngfactory.ts files, and your deployed application could be bigger. And in some cases, we know right now that you will actually get larger TS files than the template files you would have shipped before. But we're working on that. We will make the code generation smaller. And of course, we can just do that in patch releases of Angular. It doesn't affect the behavior of your program. So now I'm going to try and spend the next 10 minutes explaining how we're going to make this whole thing smaller again and fit inside of your budget. So the first step is lazy loading. And this is the biggest benefit because, of course, if your application is big and it has a lot of pages and we're trying to just show the first page and get this person, prevent them from going back to Twitter, we just want to download the code we need for this one page. So this could be a big % reduction compared with your entire program. And I won't talk a lot about how to set this up. Basically, you can look at Victor Savkin's excellent blog articles about how to configure the router. And so if you use load children in this example and you point it to a bundle that you've created that has the code needed to display the admin route, then we won't load this code unless the user goes to the admin route. The next step we want to do is tree shaking. So now that we've selected the code that we actually need to have on the page, let's make sure that we really need all of that code. And this might seem like a new concept, but actually we've been doing this for 10 years with Clojure Compiler at Google, and I'm sure that some of you have been using tools that can remove dead code also. So the idea is we can remove unused subtrees from some tree as long as we're sure that the thing we're removing doesn't have any side effects, like it doesn't mutate some global state. And this isn't possible with just a min.js script like we would have given you in Angular 1. And if you look at the new release of D3, the version 4, you'll see that they now distribute like 20 modules for this exact problem, because if you wanted one D3 visualization, you had to get the entire thing, because you can't tree shake it. But we have to have a dependency graph in order to do this, and that's cool because we have ES6 modules now, which are declarative, and they instruct static analysis tools what's the dependencies between all the files in our program. So in this example, module C is not reachable in this graph starting from the entry point, starting from the root. And so we can delete module C and all of its subtree. The same picture, but this time we're talking about individual things that were exported from module B. So function 1 is used by module A, so we can't remove all of module B, but we can remove this other section that's not actually called from the entry point. And we can keep getting fancier. We can remove individual members from a class. So in this case, we have to keep we have to keep the class B, but we can remove these unused methods from it that aren't called in the call graph. And we can get super fancy and even look at conditional code. So if we can tell statically that B is always true, then we'll never fall into the else branch, and we can delete all the code that appears down there. And that might sound nitpicky, but keep in mind that those red nodes may be the only place that references one of your imports. And so by deleting these 3 nodes, now we can go back to the first example and delete an entire module that's not used in your program anymore. Oh, my red underline moved. Sorry, imagine so now this is an editor where underlines on top of things, is what I'm showing here. So if you use the emit decorator metadata flag to TypeScript, which we've told you to do in the past, it will produce this line which I've overlined. This says reflect.decorate, and this is helper code that gets emitted into your JS, so you may never have looked at it. But the problem is that it's taking your decorators and it's storing them in this global storage. So is this code unused? In fact, this function will be called when the script is loaded, so the entire script is not actually unused, and tree shakers know this, and they won't remove this file. Even if you didn't turn on that flag, decorators themselves are inherently able to modify global state because they can just change the runtime semantics. And so the effect is that we can't tree shake anything with decorators. And this is a big problem. We want to be able to tree shake, you're using Angular material, we want to tree shake most of the components, but they have decorators on them. So this is where we use that pre-process hook I mentioned inside of NGC, and we actually strip some of the decorators that are the Angular specific ones, or we lower them into the annotation semantics, which is just static data that still works with static analysis. There's the link on GitHub to the project where we implemented that. So for example, we can completely remove the component decorator from this class. This information will have already been recorded into the metadata.json file, which is where we read it from. However, if you're using the just-in-time compiler, or in the case of dependency injection, which still has some dynamic reflection going on, We can't just delete the add inject in this case, so we turn it into what we call an annotation, which is just a static property that's declared on the class. You can see the same information is preserved in there. The JIT compiler knows how to use this, so if you have a JavaScript file with this inside, it will know how to still compile this at runtime. And the tree shaker knows about that this is not used. So if the class isn't referenced, then there's no reference into the static field, and so it can be tree shaken. So that's how we fix that. Bundling. So the next problem is that we have all of these files. So we don't really want a lot of files. Like in this case, we're importing from Angular, and then internally Angular has lots of modules, and Material has lots of modules. And so if we keep all of these modules around, we have thousands of files. We can't actually load those into the browser. It's too slow. So the first thing we could do is stick them all into one file, but still have all of the same modules. So the module number has not reduced, but the file count has reduced. And we do that, in this case example, we use system.js, and so it wraps each of them with a function closure, which is needed because some modules in ES6 can have a variable name that is scoped within that module, and it could conflict with a variable in another module. So these have to stay inside of function closures. But of course, this has to execute at runtime. Before we can get to any of our code, we have to run all these functions and do all the system register calls. So what we really want is one file. It needs to be ordered by dependencies, so we declare things before they're used. And we don't want the thousands of modules in that file. We just want to have one module in that file. So you can do this, for example, with rollup today. You can produce a single file, and it will take care to rename any variables that would conflict after they're all hoisted up into the global scope. So actually, you can go to rollup.js and play with this. Try putting the same identifier into the first file and the second file, and you'll see in the output it puts $signs to make them not collide anymore. And if you're not convinced, here's a simple example of like all of the different tools that you might choose to use. And rollup and closure compiler have the ability to produce a single module, and so that helps you a lot if you have 5,000 modules, which is probably the order of magnitude that would be possible if you used Angular and a number of other another number of dependencies. Next is minification. So minification is simply, can we keep your code structure the same as before? But just make shorter names for things. So this class, we can rename this long class name and this long variable name. And this has to be careful as well not to produce any collisions. And we can even do like really tricky things to make your code shorter. So who types undefined? Like that's really long. You could have saved 3 characters by typing void 0. Similarly for true, that's way too long. You don't ever type that. Now of course, like your code's not maintainable if it contains lots of bang 0, which is why we like static analysis tools to do it for us. And I should point out here that you should measure the compressed size. You might think of a lot of other tricks you could do, but of course, after compression, some of them don't matter. So speaking of compression, a solved problem, right? Well, there's a new compression algorithm that we suggest you give it a try. It's called Brotli, or Brotli, I'm not sure the pronunciation. So this is a Google project, there's the GitHub link. And so if your client sends an accept encoding of BR and your server supports Brotli, then you can ship down a smaller compressed file. So they claim it can be 26% smaller. We did an experiment with the smallest Angular 2 app we've made to date, which was 83K before compression, and we saved about 13% with the Brotli version versus the gzip version. And so this is something you could just enable for your app, and you would benefit from this even if you haven't done all of the other optimizations. Okay, so in 3 minutes, how will I tell you how to do all of this stuff to your app? It sounds like an awful lot of tools to configure. We don't want you to have to configure a lot of tools. And some of the tools don't work well with some of the other tools. There's a lot of configuration, and it's pretty hard. And we know that this is hard today. So as Hans mentioned earlier, the Angular CLI can actually do these things now, as of the last release. It does all of those things, except it doesn't inline the modules yet. So it still has that problem I described of having to execute all of the module function closures. But it's very new. We just released this, I think, last week. It probably has bugs, and it also is like really slow for incremental builds. We talked to the Ionic guys, and they're seeing like 30-second incremental compiles. So this is really bad to have this in your developer workflow. And we probably need to make some architectural changes in Webpack, and we need to make some changes in NGC to make it more incremental. So we will work on this and improve this story. But the lesson here is that we hope to bundle all of this up in the Angular CLI, so you don't have to know all the different tools. We'll just upgrade the CLI. And of course, your code shouldn't have to change. So this is not like a breaking change for you. It's just how can we better improve the tools to serve it faster and make it smaller. So Mark, thank you very much. He's going to talk in a minute. This is his awesome demo, so I didn't have to do a demo. So you can go to this and see all of the different examples of the different things, the different stages you could go through to make your app smaller, and you can click the GitHub link to see how he did them. So for example, if we just bundle everything together in a file, but we don't do the other optimizations, we transfer 416K. That's like most of the budget from my example earlier. But if we turn on lazy loading, so we don't load one of the big other routes, and we turn on AOT and tree shaking, it's 186K, which is a lot better. And of course, we want to keep reducing this number with future releases of our tools. So very quickly, let me tell you about what I do, which is not any of these things. So I work on the tooling at Google for how we use NGC in our apps. And most of the tooling is open source, and I think the approach is interesting, so I'm just going to touch on it really quickly. We use a build tool called Bazel, which is open source, but we haven't open sourced the TypeScript rules yet, so you can't really try this. But Bazel has this cool feature, which is that everything is in small libraries, and it's very fine-grained, and we build all the libraries one at a time. So this means that at Google, we actually use the AOT compilation even in development mode, and we're going to just take away the ability to have JIT mode except for tests. And this means we get the errors from the templates immediately, which is nice. You'd like to have that in your developer round trip. So this sounds horribly slow, but we were able to get it down in about a second. So the basic premise is that we only need to run NGC on, in bold I have this one HTML file. Let's say that file has changed. We only need to run NGC on this little section of code, and all of the other things that it depends on, we can just reuse the outputs from last time. And combined with that, we keep the TypeScript and NGC toolchain running all the time as sort of a background daemon. So we just hand it a request, and it gives us back the compiled code. We can use this in development mode. We just do an on-the-fly bundling. And then in production mode, we use the closure compiler, which is tricky to use. But by being careful, we can actually bundle all of our code per route and even per locale so that we can serve these files from something like Google static domain. So my takeaways are we want to improve the tooling that you're using already, and we maybe want to try and make it possible for you to use Closure Compiler or Bazel or some of the same tools that we are using. That's it. Here's a link to the slides. And come tell me if you want to work on static analysis tools. Thank you very much.